So if we're using the differential amplifier as part of a monitoring circuit, I've broken this down into 3 separate sections. So normally it will be connected to a Wheatstone bridge. The part in blue is the Wheatstone bridge. So the Wheatstone bridge there is used to control V2 minus V1. So it's connected to the 2 different points, here and here. So whatever values these resistors have will control what the potential is at each of these 2 points, therefore controlling what V2 and V1 are. The galvanometer, it could be an ammeter, could be a voltmeter, isn't necessarily going to always be connected in this type of circuit, but if it is, then it's used, as always in a Wheatstone bridge, to measure the potential difference between these 2 points. So what it's effectively measuring is V2 minus V1. So it's really just measuring that. Best thing to do, the reason why I've got it in different colours, is to break these down into the 3 different sections. It's easier to understand and digest that way. The thermistor there is used to control, is used to monitor changes in temperature. So this is a monitoring circuit. Whatever resistor here, whether it's a temperature sensitive resistor or a light sensitive resistor, that's what's going to tell you what it's monitoring. So this one is measuring, changes in temperature or changes to heat. If we then go on and look at the second section is the differential amplifier, which amplifies V2 minus V1, giving us V out. That's what the differential amplifier does. It amplifies the difference in voltage. So if that's controlled by the Wheatstone bridge, it's going to amplify whatever the difference produced by the Wheatstone bridge is. That output is then applied to a suitable output device. In this case, it's the motor. So it's connected to a transistor and a motor in red here. That's the transistor there, that's the motor. So the transistor is only going to switch on at a certain voltage. We talked about that. An NPN transistor like this is 0.7 volts, but it's commonly going to be replaced with a MOSFET, which we've not looked at yet, but we will kind of get a wee taster for it in a past paper question in a minute. It works in the same way as an NPN transistor does. It switches on at a certain voltage. It will only allow current to flow through it once it reaches a certain voltage. So it's 0.7 for an NPN transistor. For a MOSFET, we'll discuss that later once we get to radiation and matter. But it reaches a certain voltage, switches on, allows current to flow, switches that motor on. That motor could be replaced by any type of output device. It doesn't necessarily always have to be a motor. It could be anything like a bulb, an LED, a relay or a solenoid, anything like that. But it will usually be explained in the question what the output device is going to do. So these are our 3 sections. Blue, you've got your Wheatstone bridge determining your potential at V2 and V1. The thermistor here tells you that it's a temperature sensing circuit. It's to monitor changes in temperature. The difference in voltage here on the galvanometer is amplified by our differential amplifier there. The gain of that, as we already know, is RF divided by R1 multiplied by V2 minus V1. We then get an output out here. That output, if it's above a certain voltage, will switch on this transistor, allowing current to flow in the motor and performing some kind of action thereafter. Okay.